rock, sand, shale, oyster beds, things like that. We can actually take that and see any little breaks in the surface, faults, and we can actually tell the fluids that are there. We do rock physics. So we can tell you that if the rocks have porosity and permeability, like a sponge, if the sponge has water in it, does it have oil, does it have gas? We're doing all that. That is the design here. And if there are any void spaces or holes in the earth, it will show that. Actually, we can image the mine, the cavern. I'm hoping that we'll be able to do that, although that's not one of the requirements, but we've done it before in the past. So what we have here is an image before the cavern broke and the sinkhole appeared. So this is our snapshot in time before. In about 2 months, we'll have completed our work out there, and we'll have a snapshot of the way it is now. So we can compare it. It's like looking at pictures of when you were a little kid and you've grown up. So that's what we're going to be doing. Now, as we do this, that's a seismic image. And I wouldn't expect many people in here to understand that's what it is. And if you've looked at an ultrasound and somebody tells you it's a boy and then you get a girl, you know, you get kind of upset maybe, but girls are wonderful. But with this, what we can see are the layers of the rocks. We can see down right in here is the big hum. That's the horizon that had the oil in it that was produced right here until about 5 or 6 years ago. And if you look, you can see an edge of almost a vertical bed going through here, and then it turns and goes across the top. So I interpret this, and then I create a 3D image on the computer, and I can tell you everywhere there's a little line on here, and I know it's not easy to see, but we're getting a sampling point in the subsurface every 37.5 feet. So if you think about that, there would be about 20 of them in this room. That's how fine a sampling we're doing. The one that's there now, there would maybe be 2. So we're getting a very high resolution picture in our work. What we know is the top of the cavern. This is where this line, the seismic line, is drawn through the cavern area. The top of the cavern is here at 3,200 feet. The base of the cavern is here at about 5,400 feet. And the cavern shape is about like that. And what we're trying to decide is if we know what this looks like now, if we have a worst case scenario and the red dashed line, which was a hypothetical guess way back, you know, on day 1, it could be that bad. We can go in here, and if when I'm interpreting this, if that reflector is still there and I see it come up to the vertical reflector going there and this comes through, I'll be able to tell you what the salt is like now as compared to before, and I can tell you how big the damage zone is. So we don't really know. So that's what we're looking at. We're going to compare the before to the current and answer that question. But I feel very confident we'll be able to see if this thing has damaged any area outside of the sinkhole. And I've done a lot of seismic imaging, and I know the detail that's needed. We've designed that into this. And what we think could be happening is the little leak down here at the big hum could be carrying some gas up and oil, and it might be, instead of this big wide dashed line, it might be the little skinny yellow line. And we'll be able to tell this. So the area that we're going to cover on the ground is called our footprint. And that means at every point we will occupy a spot, either with a geophone, which if you're there when they did the other 3D, a geophone is actually about the size of this microphone, and it has a little spike on it about the size of a pencil. And we stick it into the ground. In the marsh, we stick it into the mud. And we hope we can pull them back out at the end. We always get them. And then in the sinkhole, we're going to put hydrophones, which are what we use in deeper water. Every little polka dot here on the map is a well. And within the area of our 3D seismic that we're going to shoot, there are 52 wells, which can be used now as a geologist. I could use those and give you an interpretation. But we're going to collect 43,825 seismic points. So we'll have a lot more data to work with. And hopefully we'll be able to image, the plan here is to image the edge of the salt down to at least 7,000 feet, to image the shallow section where gas is. If any gas and oil that's coming out through the sinkhole doesn't make it to the sinkhole and decides to take a shortcut at 3,000 feet and occupy a new area, we'll see it. In other words, has a new oil field been generated? We'll be able to see all of these things and then be able to direct the mitigation of drilling more wells in a lot safer manner. So with that, then there's this list of things. We're going to put 2,500 energy sources or more into the ground. That energy consists of vibrator trucks, pentolite, air gun, and depending on what other sources we might be able to turn up, that would be, my goal is to make this as minimally invasive as possible. And I don't know if you all just felt it, but a big 18-wheeler just drove by out there. Did everybody feel that? That's what you're going to feel when we're out here collecting. The seismic, the pentolite, the air gun, and the vibrators are going to be something so low in noise, you will hear and feel a truck driving down the highway more than what we're doing out there. But we know how to collect the data with that and to get an image that works. And that's important to me because one of the things that we're going to be doing here is asking your permission to get on your land and buy you corn. I'll show you a map in a minute. But we'd like to have your permission to do this because it's going to help us know what's going on. If we can't get there, then we can't know. But everything we're doing, there are more rules to doing this than you could believe, but we adhere to them. We have rules from the state, we have rules from the parish, but even more onerous, if you will, there's the International Association of Geophysical Contractors who have gone out and they measure anytime seismic work is done, what kind of damage could be done. So if it shakes your house, breaks a window, breaks your swimming pool. I did see some swimming pools out there. Man, that's pretty. But there's, they monitor everything that's going on, and we have very specific rules of how close we can get to certain things and how much energy we can put into the ground. So we're doing all of that. And just so you know, we have hired a company that will be out there and will come through and do a before assessment, take pictures of everything. They will be there when we're out operating in the field. They'll measure every little shake that goes on. And after it's over, they'll come through and they'll do an after. So if any damage is done, we know who's responsible. And it's covered. So, you know, this is what we do, this is what we have to do. And we are going to need the surface owners, which probably a good bit of you all, to give us permission to come onto your land. And if you have minerals, you can do that. I'm going to introduce some folks in a minute. And we're going to also, when we're out there, all the work we'll be doing, anybody who's out in the field will be carrying gas detectors. So if any gas is liberated, it will be measured and they'll check it and do all of the things that have to go with that. But our objectives are to image the sinkhole. How big is it really than what we measure just on the surface and with sonar? How big is it affecting underneath the ground? What has it interrupted below the ground that we can't see yet? We want to see the interface of the salt and the sediments. Those were those black and white layers, because that tells us where the salt face is. If that salt dome is moving, we have the before picture and we have the after picture. So we'll know what's happening. And then we want to look to at least 7,000 feet. The big hum is at 6,000 feet. And we will see how the oil, because we can tell the difference between oil, gas, and water, and we can tell what it was before and what it is now. We can see how much is moved, and we can see where it moved. That's our goal. And that's the bottom line there. So the effort, while small, only 2.5 miles, is probably the most intense 3D seismic ever done in Louisiana. I've only done about 80 of them, so I mean, I'm only drawing from that experience. I mean, there are thousands, but I've done a lot. But the area that we're going to cover is here. Receiver lines, the little geophones, which is really all we're asking to put in your lawn, is a little geophone with a stick about the size of a pencil. There'll be a cable, and in 3 weeks it'll all be gone. Those are the north, south, the little blue points. The red points are energy. We're going to put pentolite out in the ground, under the ground, buried in the ground, and put that in the area that's the marsh or swampy areas. We're going to vibrate the roadway, and hopefully we can get back up and around through here to do all of that. And the whole game plan here is to be out of here by April the 15th with all of this work. So, and if you remember the one for the previous one, it lasted months. So our expectations, which is what I'm charged with, and I'm an independent consultant, I am being paid to get this work done. And I was given a list of things they wanted done, and I realized the list was a little short, so I beefed it up. I explained it to them. They're willing to pay what more that costs. And we want to see that sinkhole, any damaged area out past it. Is it going to get bigger? Is it going to heal? We should be able to see that. We're looking at that sediment interface and any oils and gas and where it's moved. And, you know, one of the things that Texas Brine has to do here is get any oil and gas that's leaked up into the shallow section out of the ground so there's no hazard. But if they don't know where it is, if they're just drilling blind, they could stumble into something and then another accident happens, and we don't want that. And we can totally